In this problem, we need to show that the second partial derivative of r with respect to x plus the second partial derivative of r with respect to y is equals to 1 over r multiplied to first derivative of r with respect to x squared plus the first partial derivative of r with respect to y squared. And it's given that x equals to r cosine of theta and y equals to r sine theta. Now, what we'll do, we'll square x and add it to the square of y. So that means we will have r squared multiplied to cosine squared theta plus sine squared theta. Now, cosine squared theta plus sine squared theta, that's an identity with a value of 1. So that means yx squared plus y squared will be equals to r squared. So let's label this as equation number 1. Now what we'll do, we'll take the partial derivative on both sides with respect to x. So that means with partial derivative of x squared with respect to x plus partial with respect to x of y squared equals to partial with respect to x of r squared. Right. Now partial of x squared with respect to x, so that will be simply 2x. We have used the power rule, plus partial of y squared with respect to x will be 0 because y will be treated as a constant. Now partial of r squared with respect to x, this is not going to be equals to 0. Here r is not a constant, but it's a function of x. Now that means it's a function of x as well as y. So that means r will be partial of r squared with respect to x will be 2r from the power rule, but we'll also have to multiply it to partial of r with respect to x by using the chain rule. So that means partial of r with respect to x, so that will be equals to 2x divided by 2r, which means it will be simply equals to x over r. So let's label this as number 2. We'll come back to this in a moment. Then we will consider equation number 1 and then again take the partial with respect to y of x squared plus y squared equals to partial with respect to y of r squared. So partial of x squared with respect to y, so that will be 0, plus partial of y squared with respect to y will be 2y using the power rule, and similarly partial of r squared with respect to r will be 2r times partial of r with respect to y. Here also r is a function of y. Now we'll get partial of r with respect to y will be equals to y over r. So let's label this as equation number 3. So we'll be using it. Now if we start from the right hand side, so on the right hand side we have 1 over r multiplied to partial of r with respect to x whole squared. So let's start with this right hand side. That will be 1 over r multiplied to, so we have partial of r with respect to x whole squared, so this will become x squared over r squared, plus partial of r with respect to y squared will give us y squared over r squared, which will be over, we can we'll have our 1 over r multiplied to x squared plus y squared divided by r squared, which is simply x squared plus y squared divided by r cubed. Now x squared plus y squared, we already found that this value is equals to r squared, so this will be r squared over r cubed, which is simply 1 over r. So that means the expression on the right hand side, so this value is equals to 1 over r. So let's label this as number 4. Now what we'll do, we'll consider 2 and 3 and we'll take the partial of 2 with respect to x and we'll take partial of 3 with respect to y on both sides. So let's do that as well. So we'll take partial with respect to x of partial of r with respect to x, which will be equals to partial with respect to x of x over r. So that will give us the second partial derivative of r with respect to x, which will be equals to, so here we have r squared in the denominator, we are using the quotient rule. In the numerator we have r times partial of x with respect to x minus x times partial of r with respect to x, which is equals to r minus x times, so we have partial of r with respect to x, which will replace with x over r divided by r squared. So let's multiply the numerator and the denominator with r. So we have r squared minus x squared divided by r squared. Now we have x squared plus y squared equals to r squared. So that means r squared minus x squared will be equals to y squared. So this will be equals to, let's write it down. So this second partial derivative of r with respect to x, so this will be equals to y squared divided by r squared. Right, so we'll label this as number 5. Now what we'll do, we'll take the partial with respect to y on both sides of equation number 3. So we have partial with respect to y of partial of r with respect to y, which will be equals to partial derivative with respect to y of y over r. So this will give us the second partial derivative of r with respect to y, which will be equals to, so here we will apply the quotient rule. So in the denominator we have r squared, and in the numerator we have r times partial of y with respect to y minus y times partial of r with respect to y. So this gives us r minus y times, so we have partial of r with respect to y from equation 3, so this will become y squared over r divided by r squared. So let's multiply both numerator and the denominator with r. So I have r squared minus y squared divided by r cubed. Yeah, so I have missed a cubed here, so this is r cubed. Right. So this is partials, the second partial derivative of r with respect to y. We are labeling this, wait. So here we have r squared minus x squared. So using the same equation, we can rewrite r squared minus y squared as equivalent to x squared. So this will be x squared divided by r cubed. Right. So what we'll do, let's add 5 and 6 to each other. So we have the second partial derivative of r with respect to x added to the second partial derivative of r with respect to y. So this will be equals to y squared plus x squared divided by r cubed. So x squared plus y squared, that value is equals to r squared. So we have r squared over r cubed, which will be equals to 1 over r. So we have obtained 1 over, let's label this as number 7. So in equation number 4, we also obtained 1 over r. So therefore, we can say that the second partial derivative of r with respect to x added to the second partial derivative of r with respect to y, that this will be equals to 1 over r multiplied to the first partial derivative of r with respect to x whole squared plus the first partial derivative of r with respect to y whole squared, and both of them are giving a value equals to 1 over